one of the first things people do when they're doing an electrical installation is they learn or calculate the load that they have. So that's typically or commonly the place where people start. I have a 60 amp load. I go to table 31015B16 and I look up my 60 amp load. Right. So if you look at this table, if you had a 60 amp load and you went to this table, a 4 AWG copper conductor would suffice, or you could use a 6 AWG 75 or 90 degree conductor. So as long as you met the conditions on top of that table, that's what you would have for a conductor, a 4 or a 6, depending on which is the insulation. So again, it shows you that it's the temperature that's really a factor, not the current on the conductor.
So that's really the basis for these tables. They're based on assumptions that are being made, and you start plugging in some of the conditions of use, the factors, and all that stuff. Right?
Yeah, and if you don't take them all into account, you have a potential problem. You might have overheating, you might have the insulation melt, you might have a fire. So you could have electrical hazards, shock hazards, arcing hazards, things like that. So you really need to take all these into account to make sure your installation is code compliant.
We're talking with Chris Coache, Senior Electrical Engineer of the NFPA. You are watching NEC Connect. That's part of the community, necconnect.org. If you're a frequent visitor there, we thank you for being a part of the community. If it's your first time, click around and find all the information that's here for you. It's all dedicated to being your go-to source around the National Electrical Code. The topic of this particular webisode, ampacity and why temperature is critical to understanding wiring methods and materials. Ambient temperature. What's ambient temperature?
Ambient temperature is just the temperature of the medium that's around your conductor. It could be air, it could be insulation, it could be the earth. So it's whatever is around the conductor. And the table, again, as you look at some of these tables, they'll say buried in earth, in a raceway, or in free air. So you need to make sure you're using the right table. 31015B16 is for something that's in a raceway or in earth, that kind of thing. So it's not a free air ambient temperature.
So let's talk about another table, 31015B2. What's important about this table, and what do you want to point out with this one?
Well, 31015B2A is an ambient temperature correction. So if you look at the main table, it says it's based off of 30 degrees C. If you have something other than 30 degrees C, you go to this table and you have to do an adjustment correction. And if you look, the temperature, there's 3 different columns, so you need to know what insulation temperature you're going to use. And for example, if you had a 90, or let's pick 60 because that's probably more obtainable, a 60 degree ambient, a conductor that has a 60 degree insulation would essentially have 0 ampacity. The temperature itself already brought that insulation up to its maximum value, and you couldn't put any additional current through there. And it's also possible, especially if you're in cold places like the Arctic or Antarctic, where cold temperatures dissipate heat better than the warm temperature. So the temperature differential has a big impact on how much your conductor can dissipate the heat. So you can actually go up in ampacity if you were, say, operating at 18 degrees instead of at 30.
So these tables that Chris is talking about, obviously you can find them in the National Electrical Code. Depending on where and how you're watching this, click around and we've got links here where you can download these tables to get access for yourself about them. So another table, Chris, 310.13B3A.
Okay. Well, before we head
Did I skip ahead?
Yeah,
I'm excited about these tables, Chris.
Before we head
what did I miss?
What I want to do is kind of step through. I started with the assumption that we had a 60 degree load and we had a 4 or a 6 AWG conductor. So to show you, if it was a 40 degrees, so we're assuming now we were at 40 instead of at 30 degrees C, you would have to derate those conductors. This is what I was talking about the deratings. And if you derate because you're at 40 degrees C instead of at 30 degrees C, the 4 AWG wire for the 60 degrees C and the 6 AWG for 75 could not carry the 60 amp load. So you would have used the wrong conductor.
I see.
You'd have to use a 3 gauge 60 degree conductor to carry that 60 amp. So you actually have to move up just because of your temperature.